Sensitivity and specificity of a classification problem are derived from confusion matrix. We have already seen what is a confusion matrix, just a recap of it. So in confusion matrix, in any classification we have actual classes. Let us suppose they are positive and negative, 0 and 1, and we build the model and we predict them as positive and negative, 0 and 1. So for a good model we want to predict all zeros as zeros, so that is true positives. If by mistake we predicted a positive class 0 as 1, that is a negative class, while predicting we made that mistake, those are false negatives, because we have actually predicted a positive as negative. Then the actual class is negative and we have falsely predicted as positives, then those are false positives. The actual class is negative, we have correctly predicted as negative, those are true negatives, and we know the accuracy is sum of diagonal elements by overall number of observations. So accuracy is true positives and true negatives divided by all the values. Simply that is the accuracy, and the misclassification rate is 1 minus the accuracy, that is false positives and false negative overall all the values. So that is what the classification table or confusion matrix is. And then what is specificity is sensitivity. So let's talk about sensitivity. So out of all the positives, so in the actual class, let us suppose there are 30% of the actual values are positives. Out of all the positives, using our model, how many of them we have rightly or successfully classified as positive? So out of all the positive, what are the true positives? So sensitivity is nothing but true positives upon our percentage of true positives when compared with all the positives. So all the positives are nothing but true positives and false negatives. So sensitivity will be higher when we don't have any false negatives. So whenever we have all the positive classes, we want to predict as many as them correctly, or we want to classify them as positive only. So out of all the positive, how many have we successfully predicted as positive? Now what is specificity? The same definition when it comes to negative classes. So out of all the negatives, how many of the observations or how many of the records we have actually predicted them as negative? The true negatives overall, all the negative. So percentage of negatives that are successfully classified as negatives, that is called specificity of a particular model. So sensitivity, percentage of all the positives over a percentage of correctly classified positives overall positives. Specificity, percentage of correctly classified negatives, true negatives overall all the negatives.